Electronic configuration of alkali metals. Electronic configuration of alkali metals. Okay. Electronic configuration of alkali metals. The last electron in the outermost configuration is filled in s orbital and so alkali metals are s black elements and are non-transition metals. Non-transition metals. Okay. The last electron in the outermost configuration is filled in s orbitals and so alkali metals are s black elements and are non-transition metals okay. Alkali metals are placed in group first A. Alkali metals are placed in group first in group 1 first A of the periodic table okay. As there is no n-1 dx, the subgroup is A. As there is number n-1 into dx, the subgroup is A. Okay. Hence, alkali metals are in group first A. Hence, alkali metals are in group first A. Alkali metals are in group first A. That means 1. Okay, of the periodic table. Okay. Alkali metals are placed in group first A of the periodic table. As there is number n-1 into dx, the subgroup is A, hence alkali metals are in the group first A of the periodic tables. Okay, the general outermost electronic configuration of alkali metals is NS1. The general outermost electronic configuration, the general outermost electronic configuration of alkali metals is NS1, where n equal to 2, 3, 4, 5, 6, 7. Valence electron is 1 and group first A. Valence electron 1 and group is first, that means first A. Okay. Then you can also figure configuration of alkali metals, that is alkali metals symbol, atomic number, electronic configuration, and next is your electronic configuration of outermost cell. Electronic configuration of outermost cell. Okay. Electronic configuration of outermost cell. This is alkali metal. This is symbol. This is electronic configuration, and this is electronic configuration of outermost shell. Okay. This is the first alkali metal is lithium. The symbol of electronic configuration is Li, and the atomic number electronic configuration is 1s2, 2s1, and electronic configuration of outermost cell 2s1. Okay. Second is sodium. Okay. Sodium, Na, symbol Na, and symbol Na, and atomic number electronic configuration 1s2, 2s2. 1s2, 2s2. This is electronic configuration, and this is atomic number. Okay. This is atomic number. Electronic configuration. Atomic number first is 3. Second is 11, 1s2, 2s2, 2p6, 3s1. Okay. And outermost is 3s1. Next is potassium. Next is potassium. That is K, and atomic number 19. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. That is 4s1. And next is after potassium, next is rubidium. Rb, symbol Rb, and atomic number of rubidium is 37, and electronic configuration 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, and 5s1. That is 5s1. Okay. Next cesium. Next is cesium. Next is cesium. Cesium. Symbol CS. And atomic number 55. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, and 5s2, 5p6, 6s1. that is 6s1. Next is after cesium, francium. Francium, francium, Fr, francium, Fr, that is 87, that is 87, atomic number 87, and electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 3d10, 4s2, 4p6, 4d10, and 5s2, 5p6, 6s1, that is 1s2, 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, 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 5s2, 5p6, 5p6, and 7s1, 5s2, 5p6, 5, that is 4f14, 5s2, 5p6, and 5d10, and 5d10, 6s2, 6p6, and 7s1, that is 7s1. This is the electronic configuration. Okay, atomic configuration of alkali metals. The last electron in the outermost configuration is filled in s orbital. In s orbital, and so alkali metals are s black elements and are non-transition metals. This is non-transition metals. Alkali metals are placed in the group first A of the periodic table, or there is no number n-1 dx. The subgroup is A. Alkali metals are in the group first A of the periodic tables. The general outermost electronic configuration of the alkali metals is ns1, ns1, ns1. Okay, then n equal to 2, 3, 4, 5, 6, 7. Valence electron 1 and group first A are alkali metals. Okay, this is alkali metal: lithium, sodium, potassium, rubidium, cesium, and francium. Okay, lithium, sodium, potassium, rubidium, cesium, and francium. Lithium, sodium, potassium, rubidium, cesium, and francium. The atomic number of lithium is 3, and atomic number of sodium is 11, and atomic number of potassium is 19, and atomic number of rubidium is 37, and atomic number of cesium is 55, and atomic number of francium is 87. 3, 8, 11, 3, 8, 11, 8, 19, okay, and 19 or 18, 30, 37, 18, 15, okay, and this is 87, okay. This is the electronic configuration, this is the electronic configuration, and this is the electronic configuration of outermost cell: 2s1, 3s1, 4s1, 5s1, 6s1, and 7s1, okay. Next, studying is general properties of alkali metals, general properties, chemistry of alkali metals, and the physical properties of alkali metals. Okay, properties of chemistry of alkali metals, physical properties of alkali metals. All the elements of group first have, all the elements of group first have, all the element of group first have metallic properties, metallic properties such as ionic, such as ionic, such as ionic, ionic, lattice, lattice, ionic lattice structure, lattice structure, metallic luster, metallic luster, metallic luster, are white shining, all are white shining, white shining, white shining. Okay, metallic luster, all is white shining. Comma, malleability, 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 comma, ductility, ductility, malleability, ductility, conductor of electricity, conductor, conductor of electricity, conductor of electricity. Okay. Melting point of all alkali metals, melting points, melting points of all alkali metals, of all alkali metals, of all alkali metals, melting point of all alkali metals are not very high, are not very high, not very high. This is because only, this is because, this is because only, this is because only M negative attraction, M negative attraction, attraction occurs in lattice and occurs, occurs in lattice, occurs in lattice, and metals are not very hard. Metals are not very hard. Very hard. Metals are not very hard. Okay. Sodium, for example, can be cut with a knife. So, for example, sodium, sodium, sodium can be cut with a knife, with a knife. Sodium can be cut with a knife. Some of their important physical constants are summed up in these tables. First point, occurrence, occurrence, occurrence. Okay, first point, occurrence. The metals of this group are too reactive to be found in the free state, as these elements are found in combined form as ores. Sodium and potassium occurs relatively abundantly in nature. In nature, lithium, rubidium, and cesium occurs much less abundantly. Francium is a radioactive element with a half-life period of 21 minutes. Okay, the metals of this group, the metals of this group, the metals of this group are too reactive, the metals of this group are too reactive to be found in the, to be found in the free state. Hence these elements are found in combined form, as ores. Okay. Sodium and potassium occurs relatively. Sodium and potassium occurs relatively abundantly in nature. Abundantly in nature. Okay? Abundantly in nature. Lithium, rubidium, and cesium. And cesium occurs much less abundantly. Okay? Abundantly. Francium is a radioactive element. Francium is a radioactive element with a half-life period of 21 minutes. Okay. The metals of this group are too reactive to be found in the free state, hence these elements are found in the combined form as ores. Sodium and potassium occurs relatively abundantly in nature. Lithium, rubidium, cesium occurs much less abundantly. That means sodium and potassium occurs relatively abundantly in nature, and lithium, rubidium, cesium occurs much less abundantly, and francium is a radioactive element with a half-life period of 21 minutes. Okay, next, second point. Physical state. Second point, physical state. Okay, physical state. Then in a physical state, alkali metals are silver, white, malleable, and soft solids. They can be cut easily. Lithium is more hard in comparison to others. Okay, alkali metals are silver, white. Alkali metals are silver white. Alkali metals are silver white, malleable, and soft solid, and soft solids. They can be cut easily. Lithium is more hard in comparison to other. Lithium is more hard in comparison to other. Okay, lithium is more hard in comparison to other. Next is extractive. Third point, extractive. Next is extractive. Okay, extractive. The metals may be isolated by electrolysis of fused salt, such as halides or hydroxide, often with impurity added to lower the melting point. Okay, extraction. The metals may be isolated. The metals may be isolated by electrolysis of fused salts such as halides of hydroxides often with often with often with impurity added impurity added often with impurity added or lower the melting point added to lower the melting point. Okay, melting points, lower the melting points. Next is atomic volume. Next, atomic volume. Okay, next is atomic volume. Fourth number, atomic volumes. Okay, atomic volumes. Atomic volume. It is seen to increase in moving down the groove from lithium to cesium. This is because atomic radius also increases in the same order, hence atomic volume of lithium is lowest, where is highest for francium. Okay? It is seen increase to moving down the groove from lithium to cesium. It is because atomic radius also increases in the same order. Okay? It is seen to increase atomic volume. It is seen to increase in moving down the groove, increase in moving down, okay. It is seen to increase in moving down the groove from moving down the groove from lithium to cesium. This is because atomic radius also increases in the same order hence atomic volume of lithium is lowest, whereas it is highest for francium. Okay, next 5 point atomic radius. Okay, okay. It increases on moving down the groove from lithium to cesium. Atomic radius. It increases on moving down the groove from lithium to cesium. Okay, this is because of the presence of an extra shell of electrons. As we move down from one element to another, the atomic radii of alkali metals are the largest in their corresponding periods. Okay, the increasing from lithium to cesium. Okay, 6 point. Ionic radius. The ionic radii of cations formed by alkali metals are smaller in size than the respective atoms. And alkali metals changes into cations by loss of one electron from outermost shell, due to which outer shell eliminates itself. At the same moment, the charge on the nucleus becomes greater than the number of electrons. Thus, the electrons are attracted more strongly towards the nucleus. Okay? Hence, due to these two effects positive ions, cations is smaller than the corresponding atoms. However, ionic radii are the biggest in their respective periods. Okay? Ionic radii, ionic radii, ionic radii are the biggest. Ionic radii are the biggest in their respective period. Respective periods. Okay? Respective periods. Why? The ionic radii of cations formed by alkali metals, okay, are smaller in size than the respective atoms, and alkali metals changes into cations by loss of one electrons from outermost shell, due to which outer shell eliminates itself. At the same moment, the charge on the nucleus becomes greater than the number of electrons. Thus, the electrons are attracted more strongly towards the nucleus. Hence, due to these two effects, positive ions, a cation is smaller than the corresponding atoms. However, ionic radii are the biggest in their respective periods. Okay? Seventh point. Point number 7. Electropositive characters. 7 points. Electropositive character. Electropositive character. These elements are highly electropositive, hence they emit electrons when exposed to light. This is called photoelectric effect. Photoelectric effect is the process of ejection or emission of electrons from the metal surface when electromagnetic relations strike them. Okay? Due to their low ionization energies, alkali metals have a great tendency to lose electrons and thus change into cations. Hence, these elements possess strong electropositive or metallic character. As ionization energy decreases and moving down the group, the electropositive character increases and moving down from lithium to cesium. Okay? Then electropositive character. These elements are highly electropositive. 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 Okay. Okay. The electropositive characters. The electropositive characters The electropositive characters increases on moving down, from lithium to cesium. 8 point. Metallic characters. metallic characters. Metallic characters. Okay, next point, 8 number, metallic characters. Okay, metallic characters. Characters. Metallic characters. The elements of group first are typical metals. The elements of group first are typical metals, and are soft. Okay, all are metals but metallic character increased but metallic character increased on moving down the group. Okay, group. The metallic bonds present in alkali metals are very weak. The metallic bonds present in alkali metals are very weak. Hence alkali metals are soft and even they can be easily caught with a knife. They can easily cut with a knife. Okay. Metallic characters, element of group first are typical metals and are so soft. All are metals, but a metallic character increase on moving down the group. The metallic bond present in alkali metals are very weak. Hence alkali metals are soft and even they can be easily cut with knife. Density. 9 point. Density. Next point, density. The density of alkali metals are very low. The density of alkali metals are very low. The density of alkali metals are very low. Density increases from lithium to cesium. Lithium, sodium, potassium are even lighter than water. Lithium, sodium, and potassium. Lithium, sodium, potassium are even lighter than water. As we know that density is mass per unit volume. Density D or rho is mass per unit volume. Okay. This is because these metals have larger atomic volume, thus their atoms are comparatively less tightly packed, due to which they possess low density As we move down the group from lithium to cesium, both atomic volume and mass increases, but the increase in atomic mass is more. This is why the density of alkali metals increase from lithium to cesium. Potassium is, however, lighter than sodium. Potassium is, however, lighter than sodium. This is an exceptional case in which atom size of potassium is more than sodium. Atom size of potassium is more than sodium. Then density of alkali metal is from lithium to cesium. Potassium is, however, lighter than sodium. Potassium is, however, lighter than sodium in density. But the property of this alkali metals, increases, this property of alkali metal increases from lithium to cesium. That means density increases from lithium to cesium. But the atomic size of potassium is greater than sodium, so density of potassium is less than sodium. It is exceptional case of this alkali metals. Okay. Next is melting point and boiling point. What is the melting and what is the boiling point of metals? Okay. Melting point and boiling points. Next is melting point and boiling points. Okay. 10 number. Melting points and boiling points melting points and boiling points. Okay. Melting points and boiling points. Okay. Melting point and boiling point of alkali metals are less. They decrease downwards from lithium to cesium. Thus melting point and boiling point decreases with increase in size. Okay. This is because they contain only one valence electron per metal's atom. Thus the energy binding the atoms in the crystal lattice of the metals is relatively low. Okay. Melting point and boiling point. Melting point and boiling points of alkali metals. Melting and boiling points of alkali metals. Melting point and boiling points of alkali metals are less. They decrease downwards from lithium to cesium. Okay. Thus melting points and boiling points. Melting points and boiling point decreases with increase in size. Decreases with increase in size. Okay. This is because they contain only one valence electron per metal atom. Thus the energy binding the atoms in the crystal lattice of the metals is relatively low. Is relatively low. Okay. Next, ionization energies. 11th, ionization energies. Ionization energies. Okay. The ionization energy of alkali metals are relatively low. This is because the s electron from the outer shell of these elements can be easily taken out. Thus, ionization energy decreases and moving down from lithium to cesium. Okay. Ionization energy. Ionization energy decreases. Ionization energy decreases and moving down. Moving down from lithium towards cesium. Okay, because the ionization energy of alkali metals are relatively low. This is because the s electron from the outer shell of these elements can be easily taken out. Okay. Thus, ionization energy decreases and moving down from lithium to cesium. Next is electronegativity. 12th point, electronegativity. Electronegativity. Next point, electronegativity. Okay. Alkali metals have very low electronegativity. It decreases from lithium to cesium. Alkali metals have very low alkali metals have very low electronegativity. It decreases from lithium to cesium. It decreases from lithium to cesium. Okay. 14th point, flame coloration. Okay. On heating in oxidizing flame, the alkali metals impart specific colors to flame. Okay. On heating in oxidizing flame, the alkali metals impart specific color to flame. Okay. On heating in oxidizing flame, the alkali metals impart a specific color to flame. Okay. Element and color. Lithium, sodium, potassium, rubidium and cesium. Okay. The lithium color crimson red. Sodium color is golden yellow, and the potassium color is pearl violet. And rubidium and cesium color is violet. Okay. The color becomes dark as we move down the group from lithium to cesium. Okay. The colors becomes dark as we move. The colors becomes dark as we move down the group from lithium to cesium. Okay. When an alkali metals are its salt are heated in oxidizing flame, the electrons get excited to higher energy levels. When these electrons excited returns to their ground states, the excitation energy which had been absorbed by them is released in the form of light in the visual region of the spectrum. The emitted energy falls in the visual region and imparts a characteristic colors to the oxidizing flame. Okay. Next, colorless and dimagnetic cations. 14. 14. Colorless, colorless and dimagnetic cations. Dimagnetic cations. The ion of alkali metals elements have a similar electronic configuration like that of noble gases. They do not contain unpaired electrons, therefore the ions are colorless and diamagnetic in nature. Okay? Flame colors crimson red. Okay? And next is the physical properties of alkali metals. Okay, physical properties of alkali metals. You can show there is lithium, sodium, potassium, rubidium, cesium, and francium. Okay, then atomic number, atomic weight, atomic number, atomic weight, atomic number, atomic weight, atomic number, atomic weight, atomic weight, atomic weight, atomic radius, atomic radius in angstrom, atomic radius in angstrom, and ionic radius angstrom, ionic radius in angstrom, and density gram per cc, density gm per cc. Okay, ionization energies electron volt, ionization energies in electron volt. And next is electronegativity, electronegativity, and next is the melting point in degree Celsius, and boiling point in degree Celsius, and color metallic, and next is flame coloration, and next is atomic volume in semi-cube. Okay, lithium atomic number 3, sodium atomic number 11, and potassium atomic number 19, and rubidium atomic number 37, and cesium atomic number 55, and francium 87. Atomic weight, lithium atomic weight 6.94, and sodium 22.997, potassium 39.09, and rubidium 85.48, cesium 132.91, and 233 of francium. And atomic radius 1.23, 1.57, 2.03, 2.16, 2.35. Okay, ionic radius 0.60, 0.95, 1.33, 1.48, and 1.69. And density 0.54, 0.97, 0.86, and 1.53, and 1.87. ionization energy in electron volt, and 5.4 electron volt, 5.1 electron volt, 4.3 electron volt, 4.2 electron volt, and 3.9 electron volt. Electronegativity 1, 0.9, 0.8, 0.7, 0.05. Okay, 0.7, 0.05, and melting point 180 degree, 180 degree, and 98 degree, 63 degrees, and 39 degrees, and 28.7 degrees. Boiling point 1400 degree, 878 degree, 758 degree, 696 degree, 670 degree. And specific heat and color, melting point, white color of lithium, white color sodium, potassium are in white color, rubidium, potassium yellow, white, potassium yellow, white color, and yellow white color, and cesium pale yellow color. Okay, of cesiums. Okay, and flame coloration crimson red, lithium crimson red, crimson red, golden yellow, and violet, potassium violet, rubidium violet, and francium violet. Okay, atomic volume of lithium 12.97, 23.68, 45.36, 55.8, and 69.19. Okay, this is the physical properties of alkali metals. Next is chemical properties of alkali metals. Okay.